Alright, here we go over the practice test. Number one, identify what you have here. AB is parallel to DC, so put the markings on it. AD is congruent to BC. Again, it may not look like it, doesn't matter what it looks like, you go by the information given. So therefore, we have an isosceles trapezoid. Remember, these are called the legs. The legs are congruent and one pair of parallel sides. Remember, the true definition is at least one pair of parallel sides, but the DCAS only goes with one pair of parallel sides. All right, number two, you can look right at your quadrilateral hierarchy and you'll see the drawing just like this, similar to this, and it's a rhombus. Then we pick everything that is above the rhombus, that's connected to the rhombus above it in the quadrilateral hierarchy, which is kite directly above it, parallelogram off to the side, and that goes up to trapezoid and then up to quadrilateral. Now, don't forget on the DCAS, they do not consider the trapezoid or isosceles trapezoid as uh, any part in relation to the parallelogram. It's just the parallelogram, rhombus, rectangle, and square that they focus on in the DCAS. Okay. All right, here we have four right angles, which would be a rectangle, but then we have four congruent sides, which is a rhombus. You put the rhombus and the rectangle together, and you get a square. So square is the most specific name, and that means all four sides are congruent. So I don't have to look at opposite sides because I have x and y. They're all the same, so I can set my y's equal to each other, and my x is equal to each other. They're all equal. So get it down to one variable for each equation and solve for it right here. Okay, number four. This is a rectangle. Remember the characteristic of a rectangle, the diagonals not only bisect each other, because that's for a parallelogram, but the diagonals are congruent. So if they're congruent and they bisect each other, then these two pieces are also congruent, which makes it an isosceles triangle right here. And since they gave me this is 53, we know this whole thing right here is a right angle for a definition of a rectangle. So 90 minus the 53 gives you 37. That's what I have right here for this angle. And since then it was an isosceles triangle right here, that makes this base angle 37 as well. So then we can add that, that's 74, and subtract, and then we have this triangle right here to get this angle. 180 minus 74 is 106. And then since this told me xz is 16, that makes wy also 16, because in a rectangle the diagonals are congruent. You need to have that memorized. And they only want the distance from p to y, which is half of that. So half of 16 is 8. Number five, the interior, exterior, and sum of all the angles of a regular pentagon. This has to be a pentagon here. It could be any other type as well. It'll just be randomly generated on the test. Okay, so we remember for the sum of the interior angles, we do n minus 2, which I didn't type in here. Oh, here it is, right down here. Which I just used for this problem. But n minus 2 times 180. And pentagon's 5, so 5 minus 2 is 3 times 180 is 540 total. So that's the sum of all the interior angles. And I divide, to get one of the interior angles, I divide that 540 divided by how many angles there were, 5. 540 divided by 5 is 108. Remember, that's the interior angle. And then if I extend one of those sides out, the exterior angle is supplementary to it, which means it adds to 180. So 180 minus that 108 is 72 degrees. Now I could have also done 360 divided by 5 and got the 72 degrees for the exterior angle as well. Number 6 says the sum of the interior angles of a convex polygon. Remember, that's the only time we deal with is convex. That means that I extend any of the sides. None of them will go inside the polygon. They will all remain outside. That's the only formulas that we can use are with convex polygons. So the n minus 2 times 180 equals 900. Divide each side by 180. And you get 5 equals n minus 2, add the 2 across, and it's 7. Find the number of sides n of a regular polygon if each interior angle is 175. Remember, if the interior is 175, the exterior is 5. If I do 360 divided by the number of angles, then that must equal 5 degrees. Cross multiply, I get 5n equals 360 divided by 5 on both sides, you get n equals 72 sides. Number 7. Go over here to 7 here. Find the value of each variable for the following parallelogram. Again, remember parallelogram, not only are opposite sides parallel, not only are opposite sides congruent, but opposite angles are congruent as well. And remember, this is parallel lines cut by a transversal, so same side interior angles are supplementary. So the first thing I'm going to do is I don't want to do the supplementary part because that's got a y and an x. I want to do the opposite angles are congruent because they only have y's in them. So those are congruent. Set them equal to each other. Y is 50. Now I plug that 50 in there plus 10 is 60. So that means that's why I have the 60 written here for angle A. Remember, then these two are supplementary. So that means this has to be 180 minus that 60, or 120 equals the 4x, unless that divided by 4 and you get x equals 30. Number 8, again, we have a parallelogram. Okay, so that means these are parallel. These are parallel right here, cut by transversal, so we have alternate interior angles. So 1 is congruent to 3. So once I find 1, that's the same as 3. Well, 2 here is a linear pair, so they're supplementary. 180 minus 75 is 105 for angle 2. And of course, that puts 75 there, vertical angle theorem. And then we have these three angles add up to a triangle. 75 plus 50 is 125. From 180 is 55 degrees for angle 3. And of course, an angle 3 is congruent to angle 1 by alternate interior angles. Okay, we got our parallel lines cut by the transversal. Alternate interior angles are congruent. Okay, should know that. We've done that many a times already. Okay. Number 9, find x and y so the quadrilateral is a parallelogram, and then state the sufficient condition. That says that. Remember, the sufficient condition says, so we need to know this first, if both pairs of diagonals of a quadrilateral bisect each other, so if that equals that and that equals that, then it's a parallelogram. Okay, these are the bottom, the 5 sufficient conditions are at the bottom of your quadrilateral hierarchy. Okay, so remember that. Because you'll use that also on the DCAS, the end of the part, end of the next Monday's computerized test for the post-mod 1 test. There'll be a problem asking about the sufficient condition to show that's a parallelogram. It's not this one where diagonals bisect each other, it's one of the other 4, just so you know. All right, so these diagonals must bisect here, so that must equal that. So them equal each other. X has to be 3. This must equal this. It's going to be a parallelogram as well. So set them equal each other. Solve it. Y must be 14. So that will make the diagonals bisect each other, which then will make it a parallelogram. Determine whether the following is a parallelogram. Okay, that's the 5 sufficient conditions at the bottom of the sheet. This is not one of the 5. What's close to it is if these two hash marks were here and here. One of the 5 is, number 5 is if one pair of sides is congruent and parallel. So it's going to be one pair only right here. Not these ones here. These had to be the congruent ones in parallel. Or both these here, congruent and parallel. They're only one of each. So no is the answer there. All right, number 11. If the quadrilateral ABC is a rectangle. So again, a rectangle, we got 4 right angles. We got opposite sides congruent, opposite sides parallel to each other, and the diagonals are congruent. Okay, so it says AC, the length of AC is, okay, we had a little interruption there, so I paused the video, so we're back here. All right, so we know that in a rectangle, the diagonals are congruent, so AC equals BD. Just set them equal each other and solve, and you get X equals 10. Now go back and read the question. It says find the length from D to B. So we need to plug that back in there. 2 times 10 is 20. Ooh, plus 4 is 24. So I made an error there. Good thing I'm going over this here with you right now. It is 24. X was 10. Okay, so that was X. Didn't ask for X, it asked for the length from D to B. Okay, so another reason to go back and double check. So for example, when you're done with your test, go back and read each question, make sure you're answering it. So I did all that work right, got the X equals 10, but I didn't answer the right question, DB. I went back now and doing this and checked it and got the right answer of 24. Okay, I've talked about that multiple times, going back and rereading the question. Here's an example of why you need to do this. All right, number 12, this is a kite. Well, remember with the kite, the long diagonal, this one right here, that's the short diagonal one. Where diagonal connects So I connect a vertice to another vertice that's not already connected to. That's what the definition of diagonal is. So BD is a diagonal and AC are the two diagonals in a kite. Okay, just as AC and BD are the diagonals in a rectangle here. The long diagonal bisects each of these vertex angles. These are called vertex angles, A and C, the one that's connected with the long diagonal. So since angle A is 36, half of that is 18 on this side and 18 on this side. Angle C is 74, so half on this side and half on this side, 37 and 37. Okay, and if I measure of angle D right here, it's going to be the same as B. Okay, so I have 18 here, 37 there, plus this angle adds to 180. So what is 37, 18, 55? 180 minus 55 is 125 degrees right there for D. All right, 13, we have a median, okay, of a trapezoid. Now, in some books they call it medians, others they call it mid-segment to be consistent with, remember, a triangle. When you take the midpoints of two sides of a triangle and connect them, that's called the mid-segment. So some will be consistent with the trapezoid and call it mid-segment, others call it a median, okay, if it's done with a trapezoid, for example. All right, so we know, just like in a mid-segment, it's the sum, it's the average of the two bases. Well, in a triangle, you only have one base. Okay, so the other one you can consider 0. Here we have two bases, the parallel sides of the bases. Remember, HL and JK are called legs, not bases. Okay, so it says 18 for HJ, LK being corrected is 40. We just add those two together and divide by 2. So 58 divided by 2 is 29, equals that length. Okay, or I could take the mid-segment itself, or median itself, double that, which is what I did right here, and it equals the sum of the bases, 58. Well, instead of distributing that, I just divide each by 2 right away, got my 29, and last step, add the 9 across, you get x equals 38. You could plug that back in if you want to verify. 38 minus 9 is 29. 29 is half of 58. Okay, backside now. Parallelogram. So you got to remember your properties of a parallelogram. Opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals bisect each other, and both pairs of consecutive angles are supplementary. Remember, consecutive means one after the other. So that plus that is 180, and that plus that, which are called same side interior angles. Remember, they're also called consecutive interior angles, depending on the book. Okay, so you gotta be familiar with both. So it says if angle K right here is 3x minus 7, angle M is x plus 28. That means we know opposite angles are congruent. You gotta know that. So I set them equal each other. Get x equals 17.5. Now I go back and read the question. Find the measure of angle L. Notice it didn't give me L, it gave me K and M, but I know that these two angles are supplementary, or these two are supplementary. So I go ahead and plug that 17.5 back into here. For angle M, for example, plus 28 is 45.5. Okay, so angle M is 45.5. Well, we know these two are supplementary. Same side triangles are supplementary. Okay, so 180 minus the 45.5 gives me 134.5 for L. 15, stated if all three would form a triangle, remember we take the two smallest sides and they have to be greater than the third side. So the two smallest are 8 and 8. Is that greater than 12? Yes. Okay, cannot equal 12. Can't be less than 12. This is the longest side. It has to be greater than it. 16, find the range of possible values. So that goes along with 15 here. They gave you all three here. They only gave you 2 of the 3 here. The third one, remember, comes from subtracting the 2, 5, and adding the 2. So if x was the smallest, we know x plus 6 has to be greater than 11, so x has to be greater than 5. If x is the longest side, then 6 plus 11 have to be greater than x. So x has to be less than 17. That's how we get those two. Number 17, order the side lengths from least to greatest, given the angle measures. So I plug in the angle measures here. I know this angle corresponds with this side. So this is the smallest angle. This is the smallest side. BC or CB doesn't matter. Remember, these are segments, so you must have segment bars above them. The next smallest angle is 63, so that corresponds with side AC or CA. Doesn't matter which one you call it, as long as you have the segment bar above it. And lastly, that's the largest, so it means AB or BA. Segment BA is the longest side. Same thing here, except for going by side lengths, the reverse direction of this one. So put in the side lengths that they give you here, okay? And this time they want it from greatest to least. So the longest side is this one, so it makes this the largest angle, angle B. This is next largest, so it makes this the next largest angle. And this is the smallest, which makes this the smallest angle. Do not go by looks, go by what the numbers say. 19, classify the triangle as obtuse, right, or acute given the following lengths. This is the video I sent you on just this problem because I forgot to go over this one. So you have a video just for this one problem. The longest side, no matter where it is in the three they give you, is always C. You put that down first. Okay, and you're squaring all three sides. So 12 squared, put a blank, 9 squared plus 7 squared, the C squared, and you're comparing it to A squared plus B squared, just like in Pythagorean theorem. Okay, do your calculations, 144, that gives you 81 and 49, which gives you 130. 140 is greater, 144 is greater than 130, so it's obtuse. If these were equal, then it would be a right triangle. And if C squared was less than this, then it'd be an acute triangle. Okay, so that's how you do that one. Very simple, basic math here. All right, number 20, we're talking about this drawing down here. D and E are the midpoints, which means this is my mid segment. It's called a mid segment with a triangle versus the median or mid segment in a trapezoid, as we talked before. Okay, these therefore are similar triangles. The small one is similar to the big one here. We're going to be dealing more with this similarity all in Module 2. Dealing with these in the lengths here and here, more specifically in Module 2. Okay, so you're getting a little introduction to it with the mid-segment theorem. Okay, this has been on the DCAS. Okay, doing this, so make sure you know it. They did it with, for example, with not a slide, a swing set. They use these as the poles for the swing set, and this is the bar connecting them. Okay, in a swing set. And they want to know how long that would have to be. Well, obviously it's going to be half of the base. Okay. All right, here we go. If angle C is 64 and angle B is 37, find the angle BDE. So I just put the X right there, BDE right here. Well, we know if this is 64, this is 64, because remember these are parallel. The mid segment is parallel. These two segments are parallel. It's half of this is half of the base, and therefore we have parallel lines cut by transversal. Corresponding angles are congruent. So I have the 64 here, 37 here, plus X, that adds to 180. Triangle sum theorem. Or it's called the triangle sum theorem. Okay, X plus 101 equals 180. Subtract the 101 across, and the angle BDE is 79. If DE is 21, remember we know that's half of this, so AC must be 42. That's nice and easy with numbers. Now we plug it with, do the same idea, but with algebraic expressions to see if you can solve it in your basic pre-algebra. And DE is x plus 4, AC is 3x minus 3. We know we double this and set it equal to that. So double the x plus 4, so equal to that. Distributive property, subtract the 2x across, add the 3 across, x is 11. And go back and they just want you to solve for x. You can plug it back in and check. 11 plus 4 is 15. So that means this must be 30. 3 times 11 is 33, minus 3 is 30. So you should know that you got it right by checking it, plugging it back in. All right, number 21, last one. Centroid. So you just did a whole assignment on centroids here. Okay, you remember on a centroid, G being the centroid, the longer piece is double the shorter piece. So that's 2x to 1x is the ratio. And therefore the whole length is 3x if you want to think it every time. Okay, it's always 2 to 1 ratio. Or if you go from small to longer, it'd be 1 to 2 ratio every time. 1 to 2, 1 to 2. Okay, if I go this way, it'd be 2 to 1, 2 to 1, 2 to 1. Okay, so I told you G is a centroid, so I didn't have to go ahead and put all the congruent symbols on each of these sides to show that they're midpoints. They already told you that G is the centroid here. AG is 11. Well, we know then that GF must be half of that, 5.5. GF 5.5. You add the two together for the whole length, 16.5. If AD is equal to DC, because we know it's a median, means it goes from the vertex to the midpoint of the opposite side. So AD equals DC. So AD equals DC. Set them equal each other. Okay, subtract this across, 2x, add 6 across, 20. 2x equals 20, so x equals 10. Okay, I did that work down here. Okay, so x equals 10, but go back and read the question. They want you to solve for AC. AC is the entire distance, so I can plug into one of these two and just double it. So 10 plus 14 is 24 for this one. So this is 24. 24 plus 24 is 48. Okay, CG is x plus 6. CE, the entire length, is 3x minus 8. Well, we know this is 2/3 of the whole thing. So 2/3 of the whole, 3x minus 8, equals that x plus 6. But we want to get rid of the fraction, so multiply both sides by 3. Okay, and then we're left with just 2 here. The 3's cancel. So 2 times this equals 3 times this. I distribute that through there. Now distribute this through here. Subtract the 3x across, you get 3x. Add the 16 across, you get 34. Last step, divide by 3. This is all pre-algebra. And you get x equals 34/3. And that's what they wanted. And lastly, DG is 7. Find BG. Well, we know the small piece is half of the longer piece right here. So that makes that 14. And of course, it's also 1/3 of the whole. And 7 over 21 is 1/3. If we had the 14 and 7 together for 21, then 7 is 1/3 of the whole. All right, that answers all the questions. Now, if for some reason you still have a question on something, I'm going to ask you, what did I say on the video about that question? And so I expect you all have that written down and then explain to me what piece that you're not understanding still from it. Okay? See you tomorrow in class for your test.